In second question, we are given some statements and we have to determine whether those statements are true or false. And if these statements are true, we have to prove them, and if they are false, then we have to give example. Before we move on to solving these questions, I want to cover some preliminaries which are important in solving these questions. First one is understanding some relationships. This relationship tells us whether an element belongs to a set or not. Here X is an element and B is a set, or A is a set, and the relationship between these two is whether the element belongs to the set or not. One thing to note here is that the element X can be just a single item or it may be a set also, but for that set to be element of A, the set itself has to be part of A. The second relationship is that of subset. When we say A is subset of B, in this case A has to be a set, B has to be a set, and every element of set should belong to set B also, and here the relationship becomes subset of A. Here A does not have to be part of B, every element of A has to be part of B. So let's look at these two relationships through an example. Let's say we have a set A which has two elements, namely number 2 and number 3, and B is a set which contains 3 elements. First element is a set containing number 2, second element is number 3, and third element is a set containing element 3. And here note that in B we have a number 3 and a set containing number 3, and these two are different elements. This is just a number and this one is a set. Now if I want to check these two relationships for set A and B, say for example I can say 2 belongs to A, but in the case of 2 does not belong to B. By this I mean that B does not have any element which is just number 2. B has an element which is a set containing 2. So in that case I can say a set which has 2 as element is element of B. Same way, because number 3 is element of B, I can say number 3 is element of B. But 3, a set containing 3 is element of B, but a set containing element 3 is not an element of A, because A has an element which is just number 3, but it is not a set containing number 3. So we should be clear about what is an element, what is a set, and when a set can behave like an element. Second preliminary is understanding what do we mean when we say A is subset of B. There are two ways of understanding this concept. First is through Venn diagram. So for example I have a Venn diagram, and in this Venn diagram I have a set which I call A. Now if A is subset of B, then through Venn diagram we can show it like the circle of set A will lie completely inside the circle of set B. Mathematically, same idea is written as if X belongs to A, then X belongs to B. X belongs to B. It means that every element of A is also part of B, or if there is any element X which is there in A, then it has to be there in B also, otherwise A will not be subset of B. Third preliminary is proving and disproving something or a statement. So when we have to prove a statement, we have to give a general proof, and in this case an example is not sufficient. Whereas when we want to disprove something, we can just give a counter example. So a counter example is sufficient. Many times we are tempted in the case of proving to just give an example which shows that given statement is true, but that is not a correct answer. Fourth preliminary is how we approach a proving problem. In proving problem, we have to be very clear about two things. First is what is given, and we will always write what is given as first thing, and then second thing we will write is to prove, that is what we want to prove. And our entire exercise will be finding all the steps that will lead us from what is given to what is we want to prove, and in doing so we can use all known facts which are known to be true or correct. So let's now move to first part of second question. The first part is, if X is an element of A and A is an element of B, then X is also an element of B. And here note that here X is an element, A is a set. So X is an element of set A. In this case, A is a set, B is also a set, because A is already used here. So here A is set which is element of set B. And third, saying X is an element of B. This statement is actually false, and because we know it is false, we will show it using a counter example. So let's take A as a set containing number 2, B as a set containing another set and another set. So B is a set containing two elements. Both the elements are sets. First element is set containing 2 and second element is set containing 3. Now here I can say that 2 belongs to A because 2 is an element of A. Here I can say 2 is an element of B because this is present in set B, and I know that this is same as my set A, so I can say A is an element of B. But here 2 is not an element of B, so here I can say this is X. So X belongs to A, which is 2 here. A is element of B, but x, which is 2, is not an element of B. So this statement is false. Next we move to second question. The second part of this question, we have A is subset of B, B is an element of C, then A is also an element of C. This statement is also false, and we will show it using a counter example. Let's say A is a set that contains number 2, B is a set that contains numbers 2 and 3, and C is a set which has an element which is a set which contains 2 and 3. So C has only one element, that element is a set, and that set contains numbers 2 and 3. Now here we can see that A is subset of B because every element of A is present in B. Here B is an element of C because B as a whole is present as an element of C, but A is not an element of C because A is a set containing just number 2, which is not there in C. In the third part, we have to prove that if A is subset of B, B is subset of C, then A is subset of C. First thing is that this statement is true. Now, how do we know this statement is true? Is easy to see using Venn diagram. So we are given that A is subset of B. This in the Venn diagram I can denote by two circles, where circle corresponding to A lies completely inside circle corresponding to B. And second statement is B is subset of C. That means the circle corresponding to B will lie completely inside the circle corresponding to C. Here we can see that the circle corresponding to A lies inside circle corresponding to C. That means A will always be subset of C. So this statement is true. So this will be one way of proving that if A is subset of B and B is subset of C, then A will be subset of C. Another way of doing this will be mathematically. In doing this mathematically, we have to use all the mathematical expressions. So in mathematical proof, first we have to identify what is given. Here we are given two things: A is subset of B and B is subset of A. Sorry, A is subset of B and B is subset of C. When we say A is subset of B, this is same as if X belongs to A, then X also belongs to B, and B subset of C is equivalent to if X belongs to B, then X also belongs to C. And what we have to prove? A is subset of C, which is equivalent to if X belongs to A, then X belongs to C, right? So we have to go from what is given to what we want to prove. So first I will write, say there is some x which belongs to A. Now because we know that A is subset of B, I can say this will imply x belongs to B, and this we can say because A is subset of B. Now this will imply that x belongs to C. This we can see because we know B is subset of C, and if any x lies in B, then that x will lie in C also. So this we can say because B is subset of C. Now we started with some x which belong to A, and we have shown that that x belongs to C also. This will say that A is subset of C. Here we can say hence proved. Now fourth part of second question is, if A is not subset of B and B is not subset of C, then A is not subset of C. This statement is false. This we can see using Venn diagram also, and we can see this mathematically also. First we will do it using Venn diagram. So we have some universal set. Let's say we have A, and we know A is not subset of B, means there will be some part of A which does not lie inside. Next is B is not subset of C, that means for set C there will be some part of B that will not lie in C. This is our set C, but in this case A actually lies inside C, that means A actually is subset of C. So if A is not subset of B and B is not subset of C, that does not imply that A will not be subset of C. Now this we can also see using an example. Let's say, and that example normally is called counter example. Let's say A is set containing number 2, A is set containing number 1, B is a set containing number 2, and C is a set containing numbers 1 and 3. Here it is clear that A is not a subset of B and B is not a subset of C, but we can see A is a subset of C. Fifth part of second question is, if X is an element of A and A is not subset of B, then X belongs to B. Again this statement is false, and we will show that by using a counter example. Let's say A is a set containing number 2 and B is a set containing number 3. Here X is 2, so we say X belongs to A, and we know that A is not subset of B, but X also does not belong to B because 2 does not belong to B. Sixth part of this question is true. Here it says that if A is subset of B and X does not belong to B, then X will not belong to A. Now why this is true we can see using Venn diagram also, and we can prove it mathematically also. First I'll show it using Venn diagram. A is subset of B means circle corresponding to A will lie completely inside circle corresponding to B. So let's say this is A and this is B. Now if there is an element which does not lie in B, means it is outside B. Now that element can never lie in A. So if this green star is not lying in B, then it can never lie in A. That means if X does not lie in B, then X can never lie in A. To write it mathematically, we can say because A is subset of B, every element of A lies in B. If X does not belong to B, then X does not belong to A. Otherwise, A will not be subset of B, and then we can say hence true.